security. How forgotten foods can feed the future. Syed Azam-Ali, Crops for the Future, Malaysia.
When the Berlin Wall fell, I was establishing a research unit for tropical crops at the University of Nottingham. It's been quite a journey.
Selamat pagi. Ladies and gentlemen, you've heard a lot of presentations today, but the word agriculture I've not yet heard. And agriculture sits at the nexus of three of the major global challenges facing humanity. So let me just illustrate life on the planet and how agriculture actually touches on all three of these massive challenges. Of course, we all hear about population growth, but we're going from 7.4 billion to 9.7 billion people by 2050. We have to feed not just ourselves, but all these other people as well. And we have to feed them and nourish them. But we can't do it by taking more resources from the planet than we return. And at the moment, we take 1.7 times the natural resources of the planet every year. Now, put it into context, we are stealing the natural resources of our children because there is no planet B. And if we don't see how we can feed that population without taking the natural resources of the planet, we are going to leave a disaster for our next generations. And of course, the elephant in the room is everybody except one country in the world has accepted climate change as a reality. The degree by which it will get hotter, we're not yet clear. And it will be closer to 3.2 than the 2 degrees and less that we agreed in Paris. So what is agriculture doing about this? Here's the agri-food industry. And essentially what the agri-food industry is saying is, one big push, one big heave, and we'll solve this problem. Let's do what we do better. Let's be more efficient at global food production. And this is really the context in which this presentation is given to you. There are 7,000 crops that we have harvested as human beings, as agriculture. 4 of them, wheat, rice, soya, and maize, now feed 60% of the world's population. So let me say that again. 4 plants feed more than half the world. We must assume then all the others are either useless or there's a good reason why we shouldn't be working on them, because the 4 crops are wonderful crops. They clearly feed a very large number of people. We see this sight everywhere we go. Any supermarket aisle. I haven't yet been to a supermarket in Berlin. I'm sure it looks like that. In Bangkok it looks like that. Certainly in Kuala Lumpur it looks like that. The products are the same. The badges, the logos, the icons are the same. And actually, the ingredients are the same 4 crops. Now, what we're seeing here is 4 crops traveling around the world to feed more and more people. We don't even make those foods. They're fabricated in factories. Our food is fabricated in a factory because we no longer create food in kitchens. We don't even call it food. Sometimes you just see on the top right-hand corner there, the word fuel. We're fueling ourselves. There's a product called fuel because that's essentially what we're telling ourselves to do, is to fuel ourselves up. This does have sound, and here it comes. And what that represents is not just the 7,000 crops, but the 7,000 languages on the planet. 7,000 languages, but only 7 languages are spoken by more than half the world's population. So the 7,000 languages that disappear 1 every 2 weeks, the knowledge goes with it. And when that knowledge is not written, it's vernacular, it's lost forever. There's no record. So we now have 4 crops and 1 language, and I'm speaking language number 3. On the global scheme of things, it's the language of communication and science and publications. It's not just publish or perish, it's publish in English or perish. So as a young scientist, when I graduated with a PhD, I went to work in Africa and in India, and I saw that crops were being grown and harvested and consumed by people without any agricultural science. People like me were not looking at those crops. And there was a good reason. There was no career benefit to me to look at crops that were grown by local people, usually women on a marginal landscape or sometimes even in their backyard. So when I saw these crops, and they had names: orphan crops, neglected crops, women's crops, underutilized crops. And I came back to Nottingham as a young lecturer, and I went to my head of unit and I said, let's have a look at these crops. These are really interesting crops. I see them everywhere I go. They've been grown on a small scale. And he said, Syed, don't be stupid. If they were any good, we'd have discovered them by now. They're underutilized for a reason. And anyway, if you could do any research and it was any good, you wouldn't get published in Nature. So our problem is the career development of academics says that these crops are no good, and therefore we shouldn't invest, and of course policy and everything else follows. But I like a good challenge, so I carried on working on these crops, and I found one in particular, a crop called Bambara groundnut, growing in very small areas all over sub-Saharan Africa, almost exclusively by women. It's nutritious, it's got protein, it's low in fat, it's tasty, and actually it has resilience to what we now consider climate change. At that time, we weren't calling it climate change. And what we considered, and we started doing work on these crops, is are they fit for the future? Are they crops that can feed us in the future? And that essentially was the basis of the research we did. So how do we do it? Well, there's Bambara groundnut growing on the Sahel, the margin of the Sahara. Tough, sturdy, resilient, without any support. There's the farmers, women and their families, looking after the germplasm and making recipes for this crop. Who has all the knowledge on that crop? Mrs. Fakudze and other women farmers, because when we started work on this crop in 1987, there were 33 published papers. You talk about fake news, most of them quoted each other. There was virtually no data on this crop. And there's a phrase, when an African farmer dies, a library goes with her. Because all the knowledge in this crop was in the heads of women farmers like Mrs. Fakudze. So we said, let's have a look at this crop and see what we can do with it. And we started work in Nottingham in our tropical glasshouses. And being a tropical crop, 52 degrees north of the equator, we said, can we look at this crop under conditions which we can simulate of the tropics? And someone said before, which is absolutely true, this is what students are for. 8 in the morning, they took the covers off these plots, and 8 in the evening, they'd put the covers back on so that we could control 12 hours of day length. But these students were bright, young, largely African master students who worked with us on this project. Something remarkable happened. Forget this, the plot on the left. On the right-hand side are Bambara groundnut plants growing inside a tropical glasshouse. Under those covers, or in fact the plants that we can see that had a day-length control, have filled pods. Great, 12-hour day length, they fill their pods. They flower and they produce pods. Something on the right are those 3 rows. If I can go back, just take those 3 rows on the edge of the shot there. Those were 3 rows which we considered to be guard rows, so we didn't cover them. We just left them there and said, well, actually, it doesn't really matter, we're not going to measure them. And in those 3 rows, you saw those plants there on the right. They did flower. They produced pods, but the pods didn't fill. And this was really interesting, because we've never seen it in a crop before. Filling of pods was controlled by day length, but the flowering wasn't. And that could explain why the yields of Bambara groundnut over the continent of Africa have varied so much over the years when the crop is planted after rains. Phenomenon, but so what's the significance? Well, we started doing really much more detailed work on it. We started looking at more controlled environments because there are no varieties of Bambara groundnut. There are only land races, farmers' own seeds protected by themselves over many generations. We started looking at the first genetic linkage map of the crop to identify the variation in germplasm, and then we said, okay, we've now identified potential. Where could this crop grow without daylight, without this photoperiod requirement? Remember this control of photoperiod for fruit filling. So we produced a map of the crop on a global scale. And all the reds and yellows say it could grow all in those areas that are marked red, good, yellow, very good. And actually those areas are more than Africa. Latin America, the subcontinent of India, even if you see Southeast Asia and even Australia. And if you look carefully, you'll see the Mediterranean basin is a potential area for this crop if we can switch off this photoperiod control of fruit filling. So we looked at the best land races we could find, and we looked at a single seed descent. Could we get those plants to produce seeds that we could then use effectively as a variety? And we found a method to hybridize the crop for the first time. Now, this was remarkable because the plant on the top left comes from 5 seeds we got from Mount Cameroon, which is the center of diversity of this crop. 2 germinated, and 1 was crossed with the parent from Botswana. And we now found we could find a whole range of new material because we found a way to hybridize. If you can hybridize, you can look at elite material, you can look at material for all sorts of different conditions for the first time. And we got past that photo period problem. So if you look at the top slide, no pods. A day length controls fruit filling. The second slide, day length doesn't control fruit filling. The third slide, spreading habit with that cross and pods. Now we've got potential because we've got material that will grow outside the central tropics, and it can go into areas which we've never grown before. Now, this is a linkage. You can see the accessions. Details don't matter, but West Africa on the left, Indonesia in the middle, South and East Africa accessions on the right. That's all the germplasm that we collected. There's a link between Indonesian material and Southeastern African material. How did that happen? Africa's here. Indonesia's a long way away. When we went to Indonesia, or in fact, when I went to work at the Malaysia campus of Nottingham and we set up Crops for the Future, we found Bambara groundnut growing in Indonesia, Malaysia, and Thailand. And we found it there because you can see the genetic linkage map. Our hypothesis is that when the Dutch controlled the trade routes between Africa and Asia, particularly Southeast Asia and Indonesia, they brought with them slaves. And those slaves brought them with their own crops. So we now have Bambara groundnut growing in Southeast Asia, germplasm identified, but no history of collection of recipes and communication between those communities in Africa who own this crop and the communities in Southeast Asia who have taken this crop up. So let's go back to where we started. 4 crops feed the world. 4 crops feed 60% of humanity now. And I bet we can't imagine a menu or a meal without one of those 4 crops in it. And if there was, it would be a very interesting menu. What we've tried to do in one crop, you could do in many. There are many hundreds of Bambara groundnuts, if you like, of underutilized crops in the world. And the idea that they're all useless and that we really shouldn't bother wasting our time trying to improve them is really out of date now. Those crops have survived despite agricultural science, and what we now need to do is ask the people who've protected those crops for many generations why they keep growing them, what is good about them, and what could we improve, and overcome the constraints. Yeah, I was younger then, 20 years ago. Crops for the Future was established in 2011 as the first and only centre dedicated to alternative and underutilized crops. Enormous support from the government of Malaysia and the people in Malaysia to host that, but it's a global centre, and international partners around the world are working now with us on underutilized crops. Here's an example of novel food, and you can see at the top left-hand corner what you might see as a familiar hamburger, but of course we're now very interested in replacing meat with vegetable protein. In this case, we're replacing it with soya. We import soya to replace meat. One progress, another problem. Bambara groundnut has protein and could be grown locally to replace the soya that we have and create a vegetable protein instead of animal protein. Slide in the middle, 3D printed food. 3D printed food, hexagons made of mashed potato and beetroot. Actually, we could replace that with millet and with dragon fruit. And on the right-hand side, you can see no one wants to eat insects, but insect meal can replace fish meal so that we can use insect meal grown on, or insects grown on Sesbania to produce fish feed for fish. And therefore, we can replace this huge cost of fish meal. Not just poor people can eat this. Sorry, I got a bad throat. Moringa soup. You saw the pods just now, which were in that slide that Esther showed. The leaves are moringa, and that can make a wonderful soup. Bambara groundnut making snacks. Tortellini made from Bambara groundnut and dragon fruit. Who thinks that's a good idea? His Royal Highness the Prince of Wales launched the Forgotten Foods Network last Friday, less than a week ago, at Crops for the Future. The banquet that night at which 9, the Agong, His Royal Highness, and 7, the Sultans of Malaysia, ate forgotten foods made from underutilized crops. That's the opportunity we have to make forgotten foods of the future. So I ask two things from you. One, everybody send a recipe to the Forgotten Foods Network. Your mother, grandmother, great-grandmother, your uncle. Recipe, please. Thank you. And the other, it's not edible. The other is, if you think, when we started this, crops for the future are not a good idea, be sure that the 4 crops we now have that feed the planet are going to be fit to feed 9.5 billion people on a hotter planet in the future. Thank you very much.
Oh, you want it back?